Okay, great. Let's get started. I'm Jonathan Christensen. I'm the Group Program Manager for Real-Time Communications in the Windows organization. We've got about an hour and 15 minutes. The agenda that I'm going to go by is sort of a broad overview of RTC, what it is, what the scenarios are that we're addressing. Then I'm going to talk more specifically about some of the functional components of the architecture. I'm going to dive in a little bit into the specific deployments that you might see, and then I'm going to talk about some specific configuration settings, those kinds of things. And then towards the end of the presentation, I anticipate that there's going to be a lot of questions. I've done a number of these before, and the interactivity at the end is commonly the best part. I get to hear a bunch of your feedback. You get to ask questions that are specific to the ways you're using, and you can share some information with your peers here. So if we could hold the questions to the end, that would be great. They're trying to capture all this stuff on tape. I'll be repeating your questions so they get back on the tape and that kind of stuff. So if we can hold them to the end, that would be great. And I'll try and leave lots of time at the end to address all the questions. So what is RTC? Well, when we set out to do this, there were some basic scenarios that we wanted to cover. And we have an instant messaging product already with the Exchange IM product, but we wanted to do something that was maybe a little bit broader in scope. The first application of RTC, though, is the core instant messaging and presence application. The way that we've extended that is to add security and some increased manageability to the product. And the other way that we've extended it, I guess, is to broaden the scope, as I mentioned a couple seconds ago, to include other modes of communication. So making it a multimedia session management platform that's generic enough to handle voice, video, data conferencing, instant messaging, presence, all of these different modalities of communication. So an overriding goal also in that is to make that standards-based and to make it interoperate with the public telephone network, other assets that are in the real-time communication space. So we chose SIP. How many people are familiar with SIP here? Wow. So the last session I gave, all the hands went up in the room. So I should probably spend just a moment on SIP. SIP is the Session Initiation Protocol. It's an IETF standard. It's a session-oriented protocol for the establishment and the negotiation of protocols. There are a bunch of sub-protocols in it, like the Session Description Protocol and those kinds of things. But if you think of SIP as an umbrella, it's really the way that you start a session between endpoints and the way that you manage that session. A session can be an IM session. The session can be a voice session, a video session, data collaboration session. And we also have the ability to negotiate parameters of the session within the session. So let's say I have an IM session going between two endpoints, and I want to add some other capabilities, some other modalities. Well, that's one session, and I've added voice to it. I've added video to it. So this is SIP. SIP started its life in the M-Music group at the IETF, and you don't need to be an expert in SIP to deploy RTC, but it's worth talking about just for a second, because it's really a paradigm shift for where we're going with real-time communications. Where SIP ended up after the M-Music group is as a protocol that was sort of adopted and morphed into a voice-over IP protocol. So today, especially in the carrier networks, SIP is the leading protocol for voice over IP. So when you make a telephone call to the UK, for example, from the United States, you don't know how your actual voice packets are traversing the network. It might be TDM, it might be over a traditional circuit switch network, or it might be traversing over an ATM link over IP. You don't really know that. You don't really care as long as the voice call connects. The carriers are using SIP in the core of their networks to connect those calls together, to establish, to set up and tear down those sessions. So we thought that interoperation with that protocol would be important because we could break the barrier between enterprise communications and the carrier world, the public network world. And this is a pretty fundamental concept, right? If you can break the discontinuity that exists today between data and voice, and if you can break the discontinuity that exists today between the public network and the enterprise. For example, today in the enterprise you have a PBX. It's proprietary. The vendor owns everything about it. It's signaling, orientation, the phones that you attach to it, all that stuff. It's a silo solution. And then if you look at the carrier network, the same thing exists. Not as proprietary, more interconnection going on there. Interconnection between carriers for different standards. But for example, in the carrier world, there's been frame relay for years and years and years. Are there any interconnects for frame relay in that world? There aren't, right? You buy frame relay networks from a single vendor typically, and you set up all of these WAN links. Well, this is an opportunity to break down some of the discontinuities in specifically with respect to communications and multimodal communications. So there's another scenario that we're addressing, and that is the idea that multiple organizations should be able to do instant messaging today just like they do email today, right? Today's instant messaging clouds are typically these proprietary, centrally located clouds, and you connect outward into them. And if you have MSN or Yahoo, and your buddy has AOL, you're not talking to them, right? So this concept of federation, being able to run an instant messaging cloud within your organization on site, and then being able to connect that to another organization's IM cloud and communications network. So I guess the core concept there is that local traffic stays local. You can deploy this instant messaging cloud inside of your firewall and keep your instant messaging traffic local, right? And it's very interesting. I just went through these slides, and there was a little phone connected at that bottom thing, and then in certain modes it decides not to display. It doesn't like the image, I guess. So anyway, on that bottom little thing, there was meant to be a phone there because we're using SIP. There's an IP. There are a bunch of vendors who have IP telephones that interconnect with this infrastructure, and you can use the RTC server as a way to log in on your telephone. I'm going to talk about telephony in a little bit, but the other thing is that once you have that instant messaging cloud internal, and also you're contemplating federating it with other organizations, you probably want to encrypt the sessions. So you want to encrypt all of the different media types, right? You want to encrypt your IM sessions. You might want to encrypt your data and your voice sessions as well, and we support that. Standards-based for interoperability, we chose the SIP standard. There was something lacking with SIP when we adopted it. It was really a telephony protocol when we took a long look at this, and we joined together with a bunch of people in the industry, and we created a draft for the IETF called Simple. And Simple are some extensions to SIP to make it work for presence and instant messaging. And since then, AOL has announced that they'll use this as their server-to-server federation interoperability platform. Lotus has announced support for it. So all of the significant players in the industry have announced support for Simple, and we really think it's the momentum carrier for interoperation of IM platforms. So the idea here is that IM should work just like email, in that you have a user URI, me, jchris@microsoft.com or joe@company.com, and that should be good enough to be able to find somebody, subscribe to their presence, and send them instant messages, whether they're in your organization or in another organization, and use the standard mechanisms of the internet to get that work done. The last part about this is that at the protocol level and at the API level, we wanted to build a platform that was extensible so that we would have a lot of opportunities for ISVs. So you could embed presence in a line of business application, for example. Say you've got an accounting package and there's items in the ledger. Somebody owns those items in the ledger. Well, if you're going through that, maybe you want to be able to see the presence of that person who owns that item and start an IM session with them with the context of that item in the ledger in the IM session. So you can say, hey, how did we come to this? What is this all about? And you can have a contextual and presence-oriented session with that person. So the APIs are there for you to embed the applications within a line of business application, or for ISVs to extend this into more of the telephony-oriented scenarios, those kinds of things. And one more thing that's worth mentioning, because we're on a standard protocol, you can interoperate at the protocol level. So say you don't build on our APIs, but you build a device like a phone, or you build an MCU, a conferencing unit in the network. You can interoperate with this infrastructure at the protocol level, and that's a very important distinction versus most of where the IM platforms that are out there today are headed. So when we chose to do sort of the next generation of collaboration scenarios, and I'm going to talk about features and try to do a demo in a few minutes, but why did we choose instant messaging as sort of the killer app or the basis of this? Well, there's nearly 150 million users today. The statistics are overwhelming. They're staggering. And corporate is the largest growth segment today. So while there are only about 13, or I don't know whose numbers you look at, 13 to 20 million corporate users today of IM, that number is growing faster than any other segment. And the thing that we're hearing from customers is this isn't a teenage application anymore. IM has a lot of utility in the enterprise, and I can go on and on about the examples that people give us. But type A companies, people that really want to get things done, use it because it's real time, it's presence oriented, and it's happening. So. And people sort of divide into different camps over this. Oh yeah, my daughter uses IM, and it's sort of a toy or whatever. But the mentality and the shift that I've seen in the last year is pretty amazing. So presence is really the stimulus. I know that I use presence all the time. Presence is this idea that I can watch a group of buddies, and we call them, it's hard to say this word, presentee, a present entity. And it's a bogus word we made up for describing this. And the other person is the watcher, right? And the watcher is the person who's looking at the presence of any other URI, whether that's a person or a document, any object in the network that you can subscribe to the presence of. And in the morning when I come in, a lot of times I'll see my boss pop up, or I'll see somebody in my team, and they'll come online, and I see the little toast pop up in the bottom of the screen, and I see that they've come online, and a lot of times it jogs my memory. I think, I wanted to talk to them, I needed to give them status on something, or I had to ask them a question, and before they get busy doing other things, I can get them in an IM session, and you can transact it very quickly, right? Whereas email is this asynchronous mode of communication. You send the email, you wait 3 days, you send the reminder, then you send the ping, and then you get a response from the person. With IM, there's more urgency, and if they send you something that's not clear in the first response, you can get clarification right away. So it's a pretty efficient means of communication. It's also the lowest common denominator means of communication. We're very interested in voice. We're very interested in video. We've done a lot of work in those areas, but the IM session has something fundamental about it. It traverses any network. You can be on the slowest dial-up link, and IM still works, right? So it has this lowest common denominator effect. It's also quiet, right? So if I'm in a meeting, or I'm on the phone and I'm talking to somebody, and they ask me a question I don't know the answer to, I can go to my buddy list. I can find somebody I know is an expert in that area, and I can ask them the question, and I can get right back to them. Sort of multitasking with different modes of communication at the same time. And then, of course, the network traversal stuff, the bandwidth, those kinds of things are very cool with IM. But firewall traversal. Firewall traversal is a huge problem in this space, and I'm going to talk a little bit more about that. I'm sure there's going to be some questions about that. Firewall traversal, especially for the voice, the data collaboration, the video sessions, is an area where there's a lot of work to be done. But with IM, you can just encrypt this, tunnel it across the firewall, open just a very few ports on the firewall. There's some topologies I'll show you that overcome this. So getting IM across the firewall is relatively easy compared to the other modes of communication. So if we think about SIP, there's some concepts that are kind of worth discussing. And they sort of fit into two buckets. They fit into the sort of the client bucket and the server bucket. The SIP architecture has three basic entities within it. They have the user agent. The user agent is just the client. This is what we wrap with some UI. It's the thing that you use to start sessions, those kinds of things. There's the registrar. The registrar is a very, very core concept that's worth just conceptually understanding. The registrar is the thing that you send your register message. It's like your login message in the morning to. And when you do that, you send it your IP address. So it does the mapping between my user URI, jchris@microsoft.com, and my IP address. And what that does is it lets anybody who's subscribed to my presence or any of my watchers, it lets them know what my IP address is. Now this is all under the sheets, but it's the mechanism that provides rendezvous between our clients. And the last component, which is also server-oriented, is the proxy. And the proxy is sort of, you can think of it as your identity in the network. The proxy is a router fundamentally, and it's a pretty, proxy is a great word for it, but it's a proxy also for your identity in the network. And this is a place where you could build rules, for example. After 7 o'clock, send the phone call someplace else to voicemail without ringing my phone. If it's so-and-so calling me, send it to voicemail. If it's so-and-so calling me, send it to my mobile device because it's urgent. Those kinds of things. So that's a core functional component of SIP and part of the application architecture. That's the place where you would build those intelligent applications. It's also the place where you're going to do authentication, sort of at the server, and it's where you're going to have the directory integration occur, and where you're going to have roaming settings. Roaming settings are like, I have 2 PCs, and I've created a big long buddy list on one. I haven't ever used the IM application on the other one, and one day I log in. Do I have to recreate that buddy list, or should it roam with me? If I move to somebody else's PC and I use my username and my domain credentials and I log into IM, I want to be able to see my buddy list. So the server is a place where that can be stored and then pushed down to the client, roamed with you. The same is true of maybe your ACLs, the settings like I block certain people from sending me IM. Right? They're a nuisance and I block them. Well, if I go to somebody else's PC, I don't want them to see suddenly that I'm present, and them to be able to send me IM. I want those that block list to roam as well. And the server, finally, is the place where you manage federation. And I'll talk about the different kinds of federation, sort of the notion that there's open federation, like email is today, and a more managed kind of federation, a more secure kind of federation. So rather than walk you through each of the features of the client, step by step, I'm going to give you a demo. And the problem with doing a demo at 8:25 in the morning is that at Microsoft not a lot of other people are online, but we'll try and scare somebody up and do a demo. I can demo some of the other things in the UI as well. Nope. Okay, so this is the client. This is the Messenger 4.6 client. I agreed to do this without it being on my screen. David Simons has already sent me a message. And I've got a couple of other people online here. You can see that I divide my buddy list into the people who are online and the people who are not online. And you can also see here that I'm not signed in to all services. Well, if you look in the tools section here, can everybody see this? Okay. I look in the account section. The 4.6 client has support for 3 different back-end services. I've got the .NET Passport account. This is the MSN service, and I log into that. I've got the Communications Service account, which is this RTC account. It's the standards-based, SIP-based account. And I've got the Exchange account. Now, I don't log into Exchange because I've got this other account that works just fine for me inside the firewall. But from a migration standpoint, if you've deployed Exchange already, you can have the client logged into both, no problem, or all 3. And then you can set the preference across the top here about which one you log into first. And on my client, my preference is that I log into my internal account first. And this is because the people who are internal and on the network that have subscribed to my presence and I've subscribed to their presence are business-oriented. They're people that I work with. For the most part, they're business-oriented. Some of them are even professional. But they're not sort of on the hot list as far as being pests, are concerned. The MSN account, is people like my son, who will send me just random messages at any given time, friends of mine, people that I went to college with, that kind of thing. And typically during the business day, I don't sign into that service. I'll sign into it at the end of the day before I'm going home. If I feel like chatting with some of those people, I'll sign into it on the weekend, those kinds of things. But there are just too many distractions that come from that venue, right? So I can that's a personal preference, and I can choose to limit how I'm doing my presence information, showing my presence information to different groups of people. So the way I group this is I group it by online and offline. You can see out of the 30 or so people on my internal buddy list that only 4 are even online. One of them is busy. You can see Dutch here down in California is busy. When I mouse over one of the contacts, you can see that it says communication service. So you can tell what kind of buddy it is. If I moused over a buddy that was signed in to the Exchange backend, you would be able to see that that was an Exchange Buddy. Or if I signed into the .NET Messenger service, you'd see that it was traversing the firewall, going up to MSN, in clear text, and so on and so forth. So I know the context of the buddy based on just mousing over the icon or their username. There's something else convenient. I choose to, with respect to kind of instantly knowing where people are, I use this this nomenclature here. So their alias and their domain for the internal ones. The ones on the outside, I don't really have a choice. They set their preference for how they're displayed to me. So they might be hot dog or some wacky name. Anyway, see, Sandy K just signed in. Robert Brown was on, but he left. I'm gonna show you Stockman for a second here. So when I double click on a present, on somebody whose presence is there, I get what we call the conversation UI. This is the window that you use to do most of your communication within. And Stockman is not a person. Stockman is a bot, I guess. It's a piece of code that's running in our lab, and it's going to give me a real-time stock information. So I just have to type in the ticker. And I hate to do this. But it's good news this morning, right? We're up 18 cents. Yeah. So, but 59, ouch. So this is just going out and getting a real-time feed and doing that dynamically, presenting the data back to me. And this was just a bot that one of our testers wrote in our lab. He also decided to add audio and video components to this. So if I go over here and I press Start Camera, I can have an audio-video session with Stockman. And it turns out that Stockman is MSNBC. So I've got this audio-video session. You saw the call establishment time is, really quick, very lightweight signaling, and we just get the call and the video window up and going. And I have control of it here. I can continue with my session with Stockman. What Stockman saw on his side, or her side, well, Stockman, I guess, so, saw an invitation from me and had the ability to accept or decline. And programmatically, Stockman, because Stockman wasn't busy with another session, decided to accept. And now I'm in this session with Stockman. On my side, I see in the conversation UI there that I've sent the invitation, right? And then there's some management sort of information about what's going on in the session. He types back to me, "Hi, J. Chris, you're accessing MSNBC right now." So from this, I can also start application sharing. I could make a phone call. And that would make a phone call using this to call a phone that is associated with the other user. That information is stored in their profile, so they publish, as part of their watcher information, their presentee information, they publish their phone numbers, like their mobile number, their home number, those kinds of things. So from this UI, I can make a phone call and use the audio capabilities and the PSTN interconnection capabilities that I talked about to make a phone call directly to Stockman or somebody else. We also have a link in here for remote assistance. Is everybody familiar with XP's remote assistance capability? Yeah, great. So this provides the rendezvous mechanism for remote assistance as well. And we also provide the audio channel. So if you get into a remote assistance session and you notice there's audio enabled, that audio is coming from the RTC APIs. So they just wrote to the APIs. They use this as the audio channel for that. And I can send a file or photo from within here. Now, I talked about this sort of generic capability to do telephony-oriented things. In the 4.6 client, we introduced this little dialer application, and we'll evolve this. We'll make this actually much more contextual. We'll bring it into the main UI, and we'll bring it into the conversation UI in future versions, so that it's much more associated with the session. But in this instance, you've got this application. And this application can be used a couple of different ways. By consumers, it's used to connect to these what internally we call voice.net services. MSN has a bunch of partners, telephony providers, and it's built a service arrangement with them so that you can, using your passport, you can go and you can choose a service provider, and you can make PC to phone calls, and you give them your credit card information, so on and so forth, and they set up a plan with you, and you can make these phone calls. In the corporate context, you probably don't want to do that. So I'll show you the deployment topology in a few minutes, but you can set up a gateway within your corporate network, connect it to your PSTN assets, your PBX. This is what we've done in this case. And you can use this client to make phone calls. Now, sitting at your desk and making phone calls with Messenger is interesting, but the scenario I find that's actually really compelling is when I'm traveling. I'll be at a hotel, I have a broadband link, I'm in my room, and I want to make calls in Redmond, right? But I'm in Boston. So I paid $9.95 for the broadband link in my room. I have a VPN back into Redmond. Why can't I use this and get my corporate dialing plan back to make those telephone calls? So that's exactly what I do. I've got a high quality, low latency telephony application. I put an earbud in my ear, I use the microphone in my PC, and I'm making telephone calls right there from Windows Messenger. And I'm avoiding those, $100 conference calls from the hotel, when you check out and you see you're on the phone for 74 minutes and it was $154. That goes away. It's all within the context of that one IP connection that they provided to you. So we're not maybe the best friends of Marriott, but nevertheless, it's an application that you can use. Does somebody have a cell phone? Yeah? What's your number?
949-500-1782.
1782? Okay. So I've got his phone number in here, and I'm just going to press dial. Now it'll connect out to this gateway, Cisco SIP gateway. Go ahead and answer it.
Hello.
So you can see it's low latency, high quality voice to a PSTN asset, in this case a wireless phone. And I would say that more latency is being introduced by the mobile carrier than by our software, right? I mean, if you have a call between two cell phones, the latency can be pretty tremendous, right? The way you know this is that you start a sentence, the other guy started the sentence too, and you're jamming into each other. But our latency characteristics are under 100 milliseconds typically. And if you think about past audio applications, real-time audio applications, like NetMeeting, for example, the audio one direction was roughly in the 500 milliseconds range. And this is, they say that the acceptable scope is about 250 milliseconds. It could be as long as a second with NetMeeting. But this is, they say that the acceptable range is about 250 milliseconds. So this is outside of the acceptable range for having a natural conversation. And you really notice this when you're using NetMeeting and you're using video, right? Because you tell a joke and the guy would sit there and you go, oh, wow, the joke bombed. And then you'd see the smile, this laugh, and then the context would be weird and you'd feel funny, and then you'd go, okay, we're not going to tell jokes on NetMeeting anymore. So this is much more, sort of real time. The latency characteristics are within that acceptable range, and you can have a natural conversation. The other thing that you may have noticed is that when he talked, we didn't get this feedback loop, even though I have the speaker and the microphone here. We implemented acoustic echo cancellation in the client, so that feedback loop gets eliminated, right? So you can have a hands-free conversation. If I'm sitting at my desktop and I have a USB camera and it's got a microphone in it, that's all I need. And I'm having hands-free conferencing sessions and audio sessions with other people on the network. So that's I think a pretty good overview of the client. Let's see if we can get this back up. So if you think about the infrastructure components that you're going to need here, sort of shifting away from the user features to what it takes to deploy this stuff. First of all, you need a good network. IM, of course, is going to traverse any network, and that's not an issue. But if you're going to give the users all of the multimedia capabilities of this, you need a good multimedia-oriented network that's going to be able to handle the voice and video in real time without too much jitter and latency. We do a lot of correction on the client for that stuff, but we can't handle all of the vagaries of a bad network, right? So you need to secure the assets in the network to make this work. If you wanted to do that telephony situation, you need to deploy, a standard SIP media gateway and connect it to your PBX, right? So that's a scenario where you need to employ some more network assets. You gotta.
What is a good connection in this term? What would you call a good network in terms of a link, bandwidth?
I guess it depends how many users you're trying to support. But the typical sessions, I should repeat the question, but let's try and hold the questions to the end. This will snowball. The question was, how good is a good network, or what constitutes a good network? And it really depends on the users and their use of the different modalities. If you're thinking about voice, for example, and it's PC to PC voice, the codec that we typically use is G.722.1. It's a wideband codec, but it's wideband sampling, and it's narrowband from a kilobits per second perspective. So it's very efficient, about 32 kilobits per second per voice connection. If you're thinking about video, then it's another 128K. And if you're thinking about a data collaboration session, well, it depends on how much the user moves the mouse and resizes the screen, because all that data has to traverse the network. So a switched network, a state-of-the-art network, this is going to help the situation. This is going to make the user experience a lot better, obviously. So the next thing that you need to have is RTC. You got to go install the base SIP signaling infrastructure and the applications that go along with this. I'll talk about what those are. But this is the mechanism that lets you find the other user, detect the presence, and start the sessions. If you're deploying this in enterprise, you probably want to have integration to the directory. And if you're in some specific industry segments, there might be requirements for archiving. For example, in the financial services sector, they need, if there's an agent and there's a client and they're doing a stock transaction, or they're talking about a transaction, or any of those kinds of things are going on, the SEC requires that the communication is logged and archived and is searchable, right? So you need an archiving solution for that, and RTC provides an archiving solution in that context. So shifting back again to the high-level user features, if you look at this from a user perspective, it's really about an infrastructure for presence that has the low latency audio, has some real usability, right? The difference between our implementation of video and audio, which I demonstrated in NetMeeting, is that not only is it low latency and higher quality, but the impetus for it isn't going to some ILS directory, sorting through the whole thing and trying to find a user, or calling the user and saying, hey, what's your IP address? It's based on presence. So usability is a key theme here. Roaming features, those kinds of things. And if you look at this from the administrative side, there are a bunch of things that you probably want in order to manage this. Our goal in building the RTC server and this infrastructure is that out of the box, you can deploy this and it becomes very, very easy to manage, right? So you probably want automated policy and provisioning. What does this mean? It means that policy, for example, a group of users, you don't want them to be able to have access to the telephony gateway, right? Because there's international calls supported on that telephony gateway. So you set that in the Active Directory, and they don't have access to the telephony gateway, right? So centralized management infrastructure for that. Or you want to throttle the bandwidth that people are using. So we have a bandwidth throttling mechanism, and that gets pushed automatically down to the clients based on where they live in the directory. You're going to want to choose the authentication mechanism that you've deployed. We support NTLM, Kerberos, and Digest, right? You've got all of the popular choices there. Digest is really a choice that comes out of the SIP world and is more geared towards interoperation with other devices than it is, typically found in the enterprise. We've got all of the common Microsoft methodologies of management, MMC pages in the server to administrate this, familiar UI, that kind of stuff. We hook into WMI. It's fully scriptable, command line, all of that kind of stuff, automated install and configuration, scriptable interfaces. And also have done a lot of work with MOM, Microsoft Operations Manager. And we have a MOM pack that's part of our SDK so that you can hook into MOM very easily and you can manage this more globally with that product. And then we've tried, of course, to make it scalable, available, redundant, and we do some tricks with the product for load distribution. I'm going to talk about those in a couple minutes. So if you think about the deployment topologies, there's the single site topology. It couldn't get any simpler. You've got a server and you've got clients. And going back to this picture that's missing the little phone on it. Yeah. If you've got a simple topology, you've got a single site, you've got a single server. Now, you might want to add servers, more RTC servers into this mix. Why would you add more servers? Well, we support the notion of some specialized roles for these servers. And I'm going to talk about the roles. But you might want to also add servers for scale. A lot of things happen with the server. There's registration messages that are being sent there. There's presence that's being kept there. There's a bunch of different things. There's roaming contacts. There's data that's flowing back and forth between the clients and is being updated. And in some cases, the actual instant messages are funneled through the server. That's a decision that the administrator would make. But if you're going to archive, for example, all of your data, you need it to push through the server so you can make it land in a data store. And excuse me. That's an opportunity we give you the opportunity, I guess, to scale out by adding more servers and introducing some load balancing. So when you're deploying a single server, what do? You install the server. You run the server setup, and you do all the typical things that you do with a server for install. You get an IP address and all of that kind of stuff. In addition, to make the client provisioning very, very simple, you publish the server in the DNS. And there's a standard mechanism. With the internet and SMTP, you create an MX record in the DNS, right? And then everybody knows where your SMTP gateway is and knows where to send your mail to. Well, with this, there's an _SIP standard DNS SRV record that you publish. And that way, when the client comes online, it says, "Where's my SIP server?" And it gets the IP address of the SIP server, and the first thing it does is it sends a register message. And the server sits there and it says, I don't know this user, I'm going to challenge. And whatever authentication mechanism you've decided to use, it challenges the client, and the automatic provisioning comes in, and the client gets set up in the context that it's supposed to be set up. So there's sort of this automated process that goes on. Also, this is the place where, as I mentioned, you apply policies. You can search the Active Directory. User search is something that I didn't demo, and actually is worth talking about. User search is, as we're implementing in the next version of the client, is this capability to, if you don't have somebody on your buddy list, to be able to go search for somebody. And you want to be able to search for them in the Active Directory, or whatever your directory assets are. So you type in ROB space BR, and you press enter. And that goes to the server, and it looks for names that look like that. It does ambiguous name resolution, the same way that Outlook does with Exchange and other products. And it comes back with a list of people who match that. So there are 10 Robert Browns that match that ambiguous name resolution. If you click on one of them, our goal is to be able to show you the presence of that person unless they've specifically blocked you in their rules. Not specifically you, per se, but maybe a whole tree of the organization, or they've disabled ad hoc presence, or those kinds of things. There are privacy implications, but if they're okay with people at Microsoft seeing their ad hoc presence, then you would see the presence of that person. If they're not okay with it, they would just appear offline, right? And from that UI, being able to double-click and start a session and have an instant messaging session with that person. The utility of this is that you don't have to add that person. This is maybe a one-time only IM session with this person. You don't have to add that person to your buddy list and then deprecate them later after your buddy list grows to 300 or 400 people, right? So it's an in-band mechanism for searching the directory with SIP and starting IM sessions. The multiple site topology is really just the single site topology times 2 or 3 or whatever. So if you're geographically distributed and you've built some WAN links between your sites, you're just installing more instances of the single site. There are a couple of nuances there. You want to keep local traffic routed locally. So you don't want to use the WAN link to go to a home server and do registrations halfway across the globe. So you use the load distribution mechanisms in RTC and in the AD to specify how traffic should be routed. And this can be done with a lot of different mechanisms, but it can be just as simple as specifying in the AD which home server the person goes to. And then you want to be able to route externally to the other users and other assets on the network across the WAN links, and you do this by setting some static routing rules and using DNS routing. So if you've got redmond.microsoft.com, which is our domain here, and you've got another one in Southern California, irvine.microsoft.com or something like that, that would be used as a clue for how to route the messages across the network. Now, federation is something I talked about early on. Federation is a word that gets thrown around a lot. It's not a word that I'm really comfortable with or happy with. I think the context of federation, if you look in Webster's, it says like the joining together disparate states to form a union or something like that, as in the federal union. And you think of the United States of America, and we have this federation. The problem that I have with that is that it really implies that there's a central authority, or that there's a clearinghouse, or that there's something out there in the middle. And in our concept of federation, there isn't. There's the internet, right? And it's chaos with some rules, some basic standards. So if you're federating to anything, you're federating to those standards, to those common set of rules. And I like to think of this more as a coalition, right? So it's a group of companies or entities that decide to bring their assets together for the interoperation of some scenarios and to coalesce around those and to form a coalition based on those kinds of things. So in this example, we've got 3 different entities. One is an ISP over on this side, and the other 2 are enterprise networks. And they've decided that they're going to be able to federate. And there are some different scenarios for federation. First of all, it's important to say that federation of IM and presence is the easy thing, right? Because of all the things I talked about IM and the signaling traffic. It's the stuff that you can get across the firewalls. I'll talk about the topologies for doing this in just a second. But it's the stuff that you can get across the firewalls pretty easily. You can guarantee the quality of service of this stuff. It's just a little bit of text traversing the network versus a media stream. So this is the easy thing to do. And it's really the first goal out of the box. Now, having said that, can you federate all the other services, voice, video, data collaboration? Absolutely, but there are dependencies. And this is where there's an opportunity to become very, expert in this stuff and to offer whole solutions for customers for getting this kind of stuff done. And while I think presence in IM is going to be federated broadly, those are going to be more case by case, or in the sort of the closed notion, the managed federation cases between entities. For the short term. Over the long term, I definitely think that this stuff is going to become widely used and fairly ubiquitous, and the standard mechanisms for getting across the firewalls and doing the IM and presence session will start to apply to the media as well. But as I've mentioned over and over again, this works with standard internet mechanisms. DNS SRV records, just like SMTP. If I send a request to become a watcher of somebody at Cisco, all I'm doing is saying, add a buddy, joe@cisco.com, send. And that traverses the network. DNS records are queried, and the request lands at _SIP, or SIP.cisco.com, finds the SRV record, and that is passed on to Joe. Joe then has to make the decision: do I want to let Jonathan be my watcher? And he can allow or block me at that point. So there's really two different concepts of federation that we support. One is this notion of open federation. Email is open federation. I can send mail at Microsoft to people who work for our arch enemies, the Suns and the, whoever they are, right? And our SMTP gateway doesn't block that. Our administrators don't say, no, we're only going to send mail to, these domains. It's open federation. It's ad hoc, and it just happens. The difference with this is that you have the opportunity to do that open federation and at least have it encrypted from hop to hop. So as it's traversing the network, the internet, you can have those hops encrypted. Is that security? Well, no, there's lots of ways to get into that. What about the hop after the hop it landed at Cisco? And inside the Cisco network, are they still encrypting? Those kinds of things. Those are out of your control, but at least you can. It's better than SMTP. It's encrypted across the internet. Then there's the notion of lockdown federation, and this is where you have a coalition, a manufacturer and its suppliers, as an example, and it's the managed case where you have a shared secret. You set up a lockdown network for sharing information across the internet, or even setting up a VPN. You can use this with IPsec and a shared secret, but you could also see this in the VPN case across those networks. And today we have a lot of extranet VPNs. So this is sort of the managed case for these real-time communications. So I talked about server roles. I'll give you just sort of a brief outline of what the server roles are. There's a home server. Every user has one. My home server is where I register. It's where I send my searches to. My presence is monitored there. There's a presence agent server. This allows me to have multiple points of presence. For example, if I have two laptops, I'm simultaneously logged in on them. I can have the presence agent server knowing where to send the IMs to based on activity on those laptops. Today, the behavior is if you log in from one computer at work and then you go home, you log in from a computer at home, the one at work gets logged off, right? It gets forced off the network. So it's the last one you logged into. The home server actually has this concept of a presence agent server that's managing that for multiple devices. This gets very useful when you have other devices like a telephone, for example. We're working with a vendor today who's building a telephone. It's a SIP telephone, but it registers with our presence agent server, and it allows the telephone to throw events to the presence agent server that are within the context of telephony. So when I take the phone off hook, my watchers see I'm on the phone, right? And when I want to call somebody, I press the down arrow on the phone, I see my buddy list. And I can go through my buddy list and I can call them directly from the buddy list, right? So pretty powerful notion. And that's what the home server provides. The load distributor is same software, but set up in the topology to do a different role. And it just distributes load to the right RTC home server, and is fairly passive in nature. Doesn't do the registration, isn't the place that you're going for presence, those kinds of things. All of the home servers, by contrast to that last statement, are load distributors. So you can have a number of home servers that are acting in concert with each other to distribute load of a user base, for example. And this is primarily the registrar, but we load balance other things too. But if you think about the registrar, this is where the mapping occurs, the URI to IP address. That's a big in-memory database, and you might want to spread it across a few machines. The load balancer does that. And then there's an edge server. There's really two types of edge servers, there's internal and external. I'm going to show you a drawing to enumerate that. But an external edge server, for example, is a box that you stick out in the DMZ, and it's accepting inbound messaging, SIP signaling, and it's forwarding it into the internal network. It's not authenticating it, it's not doing anything with it, it's just routing it correctly to the inside of the network. It's also acting as a deflector shield. So if somebody wants to send traffic to that edge server and bounce it off of that to spam a whole community, it will detect that and it'll drop those messages and it'll forward messages to the authentication server on the inside. So the SMTP spam attack is something that we've contemplated in this. So I said I would have a topology diagram, and here it is. There are a bunch of different components on here. I've got, it's hard to see probably for you, but I've got company A here, location 1, the big box. The box on top, the little box on the top, is company A, location 2. So that's just a remote office, a branch office, and we've got some firewalls there. The assumption with company A, location 1 and 2, is that you have a WAN link between those two offices. The assumption in this drawing. Now, it doesn't have to be the way that you set this up. But if you make that assumption, you have TCP, full connectivity between those sites. It really looks like one site. The main difference is that you may want to have a home server deployed out there so local traffic is staying local and not clogging the WAN links. The other scenario is down here is company B. So this is a federation scenario. You've got IPsec or HTTPS tunneling going on between these two sites, and you've got this notion of an edge server in the DMZ. And this edge server is, classic DMZ example, is a box that's sitting in the DMZ and is configured by the administrator so that the other firewall trusts this box to go to a specified set of ports and to talk to a specific server on the inside so that it can't be used to launch attacks sort of randomly across a wide range of servers or devices on the inside of the network. The other assets that I show here are the PSTN gateway, the IP PSTN gateway. In our lab, we're testing with a number of different vendors, Cisco, a bunch of others, and connection to the PBX. I've also got a Pint gateway there. This is a third-party call control scenario that we enable. We're not firmly committed to shipping this. It's an interesting scenario, but there are some issues with usability that we're working through. But the notion is that use your computer to call people on the PSTN, and the user the user behavior is you go to Outlook or you go to your buddy list and you press call, but you choose that you want to call from phone to phone. And what happens is your phone rings, you pick it up, and you hear the call queued, and the other phone rings. Now you're in that call, and you want to add somebody else to the call. You just drag and drop them into the call, and then another line gets set up. So it's really sort of a cheap conferencing resource in the network to do with this ad hoc conferencing and click-to-call scenario. You know, the thing that I'm always doing is I'm going into Outlook, I'm finding somebody's phone number, I pull it up on the screen, I reach over to my phone, I start dialing. What if you could just click and it happened, right? So it saves a step or two. It's an ease-of-use kind of feature. I'm going to talk just quickly about configuration steps. So the first things that you want to do when you're looking to deploy an RTC instance, you know, in a topology, is you want to probably enable or disable the users that are going to be able to have access to this. And you need to assign the SIP addresses, do the DNS SRV record, those kinds of things, and then assign the home server. This is pretty straightforward. It's right there in the server UI. There's some other things that you might want to do with respect to global settings. These are out-of-the-box configurations that should be adequate. But because of the vagaries of different network topologies and preferences, there might be things that you want to go in and tweak, like the registrar timeouts. I think that they're set to 20 minutes by default. You might want to clock that down to 5 minutes so that if a server goes out, the maximum amount of time that registration information is stale is 5 minutes versus 20 minutes for a user. Those kinds of things, and those are configurable within those settings. If you wanted to do user search between corporations and give somebody access to your user information, so your directory information, what people's phone numbers, some limited set of that, say person's name, email address, and phone number, you'd have to give them a guest account to the search capability, right? So they could send a user search request within the context of Cisco from Microsoft, and there would be a user account that would need to be set up, a guest account. You might want to manage policies, and we do this using the group policy object in Active Directory. So this is where you could create generic allow block lists, right? So you could say that nobody in the support group can see the presence of the people in the product team, or something like that. And, who knows? Administrators may want to do this sort of on a global setting. You might want to set like bandwidth controls, as I mentioned earlier, and you'd do this in the GPO. So you'd say, oh, people in this subdomain are limited to 100K because the people in that subdomain are on an older network. So we're just going to say, nobody's going to be able to hog the network bandwidth in that domain. And then you can get down to the nitty-gritty, and you can set the settings of the specific servers. You can do stuff with the SIP stack, for example. You can specify that you want to only use UDP, that you want to use TCP. TCP is more reliable. The network drops a lot of packets. Let's use TCP as the transport for SIP. You can leave that wide open and let the server decide. You can say that all of the traffic coming to and from the server needs to be encrypted. Let's use TLS. You can set the listening addresses and ports. These are set by default for you with the standard SIP ports, which are 5060, 5061, but you can go in there and tweak that. You can choose the authentication type that matches your deployment, and you can configure any static routes. A good example of a static route might be, I've deployed a telephony gateway, and I want to look for messages that are coming from the client that have a telephone number in them, and route those invites to the telephony gateway. And you can just create a static route for that, and all of a sudden, all those invites get automatically routed to the gateway, for example. Or there's a group of users that you want them to use a different set of assets, and you want their next hop routing to be a different gateway than another set of users, and you would do that as a static routing rule in the routing table. Now, I've talked a lot about telephony integration. I don't want to belabor the point, but I think that telephony integration is really the differentiator for RTC versus a lot of the competitive products. The uptake that we've seen in the ISV community with respect to telephony is amazing, and the presence and telephony are an incredible combination, the same way that instant messaging and telephony are an incredible combination. If you know that the person is there and they're not busy, your call completion rate goes way, way up. It provides a stimulus for this kind of thing. And having presence information on your IP handset, for example, is a very powerful tool. And having that interoperate with your data network and the data-oriented scenarios is a pretty powerful concept. So we do a lot of testing in this arena. We're working with the leaders in the industry, Cisco, 3Com, Nuera, VegaStream, people like that who build these gateways. The gateway that I mentioned and that I used for that phone call to the cell phone was a Cisco 2600 that's sitting in our lab. It's a cheap, off-the-shelf, easy to deploy. Stick a PRI line in it, or even just stick one phone line in it, or 2 phone lines, or 3 phone lines in it, and suddenly you can have users making those kinds of telephone calls. And we're working with all of the vendors of the phones as well. So Cisco, Polycom, Siemens, and there's some really exciting things coming from these people. As you know, Polycom makes these conferencing acoustic echo canceled, really, really nice in-room systems, and we're working very closely with them to integrate all of the scenarios, not just the phone, but they have an in-room video system, for example. Well, what if you can't make the meeting in the room, but you still want to join the session? You should be able to go to Windows Messenger and just join that meeting from Windows Messenger, and those are scenarios that we're working with the industry on. So, here we are. Are there any questions? Yeah. Go ahead.
I have a quick question. What if, say I've already deployed Exchange 2000, but I haven't done the IM component? Would you recommend to do it through Exchange or through .NET?
The question always comes up. And, okay, so the question is, if you have Exchange 2000, You haven't done IM yet. Should you roll out Exchange 2000 IM, which is a service within the Exchange product and part of the Exchange CAL? And as I say, the question always comes up, and it's one where I'm sort of torn, because this technology is really discontinuous from that, and the timing is not excellent. You know, the uptake of IM is pretty steep now, and we're not ready with this product. We are deploying with a number of JDP customers, and we've deployed this internally here, but it's not, the schedule for release is not set, and betas are sometimes painful for customers. So as a mainstream product, would you roll out with the beta? Well, that's a tough call. And it leaves us open to our competition a little bit for some period of time. I know that at the end of this path, we have the solution, and we have the superior strategy. This interoperation, the standards-based approach, I'm very confident in it. We're doing lots and lots of work with the user interface. It's going to be good stuff, but there is sort of a transition period now. Now, there are things that you can do to mitigate a migration, the pain of a migration. So if you go out with a trial of Exchange IM, the client is triple stacked. So as you add the RTC servers, you can just point the client to the RTC servers, and you can start to migrate your buddies over to that system. And that's how a lot of people in our group did it. Some of those people came from the Exchange IM team, and so they were avid users of that, and they all had buddy lists like that. After a while, all those buddies migrated over to the other platform. And we may create some scripts and tools to make things like buddy list migration and the settings in the home server, the policy settings and those kinds of things, migrate over to RTC. But if you have a large population of Exchange IM users, 10, 20, 30,000 users, and you want to migrate over to RTC, I would be kidding myself if I was going to say that was going to be just easy. So I'm sorry. I hope that answers your question. Anybody else?
How will this product be packaged?
We haven't made any decisions with respect to packaging. We have a lot of ideas, but we haven't made any decisions. It's very likely that the product will be a separate CAL versus the way our IM product is marketed today. This is a pretty significant market opportunity, we think, especially with where we're going beyond just the IM scenario. And so there's likely to be a separate CAL, but we haven't made any firm decisions on packaging. Yeah?
How much of the feature set have you tested with terminal server?
How much of the feature set have we tested with terminal? Oh, so from the client perspective. Yeah, it's interesting. I do it all the time because I RDP remote test the same protocol and basically the same settings. So the question was, how much of the feature set have we tested with terminal server? And we haven't tested against terminal server. It's not one of our test scenarios. The IM stuff works fine. The client works in the context of terminal services. For that basic scenario, the one wish or the one ask that I would have is that we had a less monolithic client so you could run more instances of it without having the memory requirements, all those kinds of things. But voice and video and those kinds of things, terminal server is a high latency experience, and it carries the audio and it carries the video, but it's not. You get back to that net meeting feeling, Yeah.
Is it possible with the integration with other services, or where is that falls in, like the forbidden word, the AOL and the Yahoo?
Yeah. So the question is, how will we interoperate with other services? And our position is that's SIP and simple. And the AOL guys, as a consequence of their merger, had to show the FTC a plan where they would open up their instant messaging cloud if they added supplementary services to it, like voice and video and others. And in their filing to the FTC, they said that their protocol of choice for interoperation was SIP and simple. So the architecture is probably likely to look like edge server, edge proxy, static routing rule for a set of URI and a connection to one of those services via SIP and Simple. And this is our plan for interoperation with respect to both our corporate assets, the RTC stuff, and also the MSN user base. And I think that it's gaining steam. I think that that's the way that it'll likely go. Yeah.
Right now, a lot of us use like things like Blackberries or Mobitech networks to do essentially instant messaging wirelessly.
Yep.
What are your plans there? Like I know Motorola.
Is that Yeah. Okay. So the question is, what are our plans to interoperate with BlackBerry and those kinds of?
Or at least to have a wireless service.
Yeah, a wireless service for instant messaging. So I've got a question back to you. Is that an instant messaging application that you're using, or is it a mobile email application?
This here?
Yeah.
Essentially, it's mobile email, but when you're using the Mobitech network, it's more of a pin-to-pin type scenario that's just parallel. It's definitely not IM.
Okay.
But I would like to have this on MSN or corporate enterprise network through IM rather than have to go through another provider that gives me,
Right.
certain limitations.
Right. So the answer then is that this is definitely on our roadmap. That as SIP and Simple take off, the gateways to SMS services and BlackBerry and all those kinds of things will be well established. Today we have a prototype that allows us to set presence on the presence agent server as mobile, and when it's set as mobile, to forward IM sessions to SMS gateways and to land on a mobile phone, for example. And if that happens, to be able to generate a reply and have that routed back to the corporate network and land back in the instant messaging client. So it's definitely something, and the financial services sector really talks a lot about these mobile devices and enabling them. So it's definitely something that's on our roadmap. And I think that third parties are going to come in with solutions for this as well. There are a lot of vagaries in this space, right? There's a ton of different operators, lots of different standards. So I think that a lot of that's going to be filled in by third parties. Yeah.
I'm interested in the voice over IP aspects of RTC.
Mm-hmm.
It seems like there's similar functionality features that Cisco's call manager and Unity support. Is it going in that direction to be a direct competitor with other voice over IP innovators?
Right. So the question is, are we targeting applications like Cisco's call manager and Unity with the RTC infrastructure? And the answer is that we're complementary. So do we believe that call manager will continue to have its own soft phone experience? Yeah, probably. They have their own UI and features they want to expose that are specific to their system. But God, we hope they use our APIs and our low latency audio, and we hope that someday they embrace SIP instead of the proprietary protocol that they're promoting today. So that we can have interoperation of these services. Now, having said that, we're working very closely, I can't mention names, with a number of people in the industry, people that, the obvious choices, who have developed complementary products like voicemail systems and video mail, voice, video, and IM mail systems, so that real-time sessions can be transported to a unified messaging infrastructure. And we're not building that, right? They're cooperating with us at the protocol level, and we're making that stuff interoperate. So I think for the most part it's complementary. There is some disconnect with us in the industry on protocols. There's the people with proprietary protocols. There's the people who are still sort of stuck in the H323 world, and there's the people who are moving towards SIP. The introduction of 150 million SIP enabled endpoints with the run rate of MSN Messenger and Windows XP and all of our down-level capabilities to 98, 2000, NT4, all that stuff. I think that's going to change the game a little bit. So I see it being a SIP world in just a moment's notice, really. Yeah.
Two questions.
Yeah.
Sort of philosophy with the roadmap. Is IM developed by a completely different group from the IM exchange? Is there two different products that at the end will merge or replace replace each other?
No. The question is are there two different product units working on IM at Microsoft? The Exchange IM team is now reporting into our team, and they are working on RTC only. The only thing that goes on for Exchange IM is bug fixes, service packs, those kinds of things.
So it's going to be replaced?
Yeah, this is RTC is the next product suite for that problem space, for that or opportunity. Yeah.
The other question is, in case you have firewalls within a cloud.
Yep.
I'm having this scenario right now with a customer, and with IM in Exchange, we have a problem because, as far as we know, the conversation between two clients is not routed between the routers, but routed between the client and the adjacent server. So if you have a firewall between them, you must open the ports to all clients, to all servers.
Yeah. So the question is, how do you overcome internal firewall issues? So you have a network, and then you have firewalls within that network. And I think that RTC is as flexible as possible with respect to that. First of all, we can tunnel over well-known ports that are probably open on those firewalls. The other thing is that we don't require that the message traffic goes to the server when you're going between two clients in a specific part of that cloud. So if you've deployed the server someplace else, you don't have to route it across the firewalls and back. You can do it peer-to-peer. But those topologies are always going to introduce complexity into the situation. The topology was probably designed for and then tested against a set of specific existing applications, and new applications come in all the time, and people have to sort of adjust their expectations about their security topology. So there's no sort of magic bullet. Yeah.
Question on journaling, or whatever you call it in instant messaging. I know Francis D'Souza's company had IM Logic. Is this similar to that, or does it replace that, or it's just marched up to condition of that you're coming out with for RTC?
Yeah. The question is, are journaling, there are third parties building journaling products for Exchange IM and probably for RTC when it comes out, and does ours replace or whatever? There are a lot of different requirements in the market for archiving, and people will verticalize their solutions, is my anticipation. We are trying to build an archiving solution that meets the SEC requirements and is broad enough and flexible enough to meet most of the other customer requirements, and we're shipping it with a product. So that's the best I can do on that. Yeah.
You mentioned that edge servers could filter or stop spam. Is this a part of RTC?
No, so the scenario that we are avoiding, the question is, can the edge server filter or stop spam? The scenario that we are trying to avoid is, and I hope that we've succeeded, is with an SMTP server, if you have it sitting on the internet, really one of the only popular mechanism of not letting anybody exploit that as a forwarding server for their spam is to do a reverse DNS lookup, and to check the domain from which they're coming. And if they're not coming from your domain, you don't forward their mail. Well, in the SIP world, you have these edge proxies sitting out there, and you want to do something similar. You want to enable the edge server to forward specifically to an authentication resource, and not to take unauthenticated traffic and turn it into a spam router. So, for example, if you turned on a record route header on that server, one of the scenarios might be that you come from evil guy domain, and you hit Cisco's router, their edge server, and you want to send IM subscriptions to somebody at Microsoft, billg@microsoft.com, right? It looks like it's coming from Cisco. right? And that's the scenario that we wanted to avoid. So we've built some logic into the server that doesn't let that happen. Yeah.
How easy is it to automate the sending of this?
How easy is it to automate sending instant messages with?
Instead of a service which is some alert function,
Yep.
when it actually sends alerts using
So the RTC client API is a user agent, and one of the scenarios that we specifically targeted was a scalable alerts engine. So you can just write a piece of software, that does all the rules or whatever for your alerts, parses your alerts, packages them for a group of users, whatever, and you can just shove them through that API, and that API will deliver them, like a machine gun to all the end stations. Yeah.
I recently, using the MSN Messenger, I renamed my passport, or I changed the naming of it, and I had to re-register all my contacts and all that kind of stuff. I can envision in a corporate scenario, if there's mergers, acquisitions, and using passport to, presumably you can use passport to authenticate. What happens if you change the whole, part of the passport that has the company name in it? Is that something that you're looking at? Is it easy to take a whole IM domain and shift it to another naming?
Yeah, the end user's passport shouldn't matter as long as their resources in the network are preserved for them. And that's really an administrative thing in the directory. And the buddy list, for example, is an XML document that's stored there, encrypted, and so on and so forth. If their passwords and permissions migrate, their XML document comes down to their client. They keep their buddy list and their ACLs and all that stuff. I think we're running out of time. Yeah, we're out of time. So thanks a lot for coming.